So this is another numerical question. Calculate the wavelength in nanometer associated with a proton moving at 1.0 into 10 to the power of 3 meter second inverse. And you are asked to determine in nanometers. The wavelength should be in nanometers. So we know the how to calculate the wavelength of a moving particle in theoretical chemistry. It is by the de Broglie equation. What is de Broglie equation? The wavelength lambda will be is equal to h divided by m into v, where h is the Planck's constant. Planck's constant. M is the mass of moving body. And v is the velocity. So let us substitute those. So lambda is equal to Planck's constant, we know it is 6.626 into 10 to the power of minus 34, and its units are meter square, kilogram, second inverse. Now mass of a proton, very important, this you should by heart, there is no other way. Mass of a proton is 1.673 into 10 to the power of minus 27, that is in kilograms. Of course, SI units is in kilogram. So you should know the mass of proton, mass of electron, etc. You should by heart it. Now velocity, it is given as 10 to the power of 3 meter second inverse. So since it is same SI unit, you don't have to do anything, so you can directly substitute. So what will be the value of lambda? Lambda will be equal to 6.626 into 10 to the power of minus 34 divided by mass is 1.673 into 10 to the power of minus 27 into velocity is 10 to the power of 3. So as I said earlier, we will calculate it as 6.626 divided by 1.673 into 10 to the power of minus 34 here. It will be 10 to the power of minus 27 is here. So minus 27 plus 3. So that will be minus 24. Minus 24. So once it goes there, this will be equal to 6.626 divided by 1.673 into 10 to the power of minus 10, and that will be in meters, because you have calculated here as meter square. Lambda, not the lambda, this is h value, it is in meter square. This is also in meter, so once you calculate it, it will be in meters. Now 6.626 by 1.673, how to do this? It is better to multiply by, we need only 2 decimal places, so if we multiply by 10 on both sides, numerator and denominator, you will be having 66 divided by 16.73, or you can approximate it as 66 divided by 17. So if you take 66 divided by 17, let us try 17 into 4. If it is 17 into 4, 7 4 is 28, 2 1 2 plus 68. So it's a bigger number, so you have to try 17 into 3. 21, 2 1 3 2 is 51. So it will be 3, and here will be a 51. So the remaining part will be 5 1. So 1 5. Now you should have a 0.3. Now 150. So it will come 17 around into 9. So this will be like this is equal to 3.9 approximately, not saying the exact value. 3.9 into 10 to the power of 10 meters. What will be this one? This will be approximately around 0.39 nanometers. In nanometers it will be 0.39, because 10 to the power of minus 11 meters is the 1 nanometer. Sorry, minus 9 meters is nanometer. We know 10 to the power of minus 10 meters is 1 angstrom. So this is in nanometer. 0.39. If you check the options, let us see the options. Oh, here you have approximately 0.40. So you can take this option as the right one, 0.40 nanometer. Remember, this is a numerical question, so you have to do without using the calculator.